Hello students, my name is Fizwell from Umgungundlovu TVET College. Today we are looking at NCV Level 2 Mathematics. Our topic today is functions and algebra. Our subject outcome is subject outcome 2.2, where we are going to manipulate and simplify algebraic expressions. Our learning outcome, the first learning outcome, is to work out the product of a monomial and a binomial. The second learning outcome will be to find the product of two binomials. We are also going to include a perfect square. The third learning outcome will be working out the product of a binomial and a trinomial. In terms of our pre-knowledge, which is the learning that has happened at grade 8, grade 9, we have learned about the monomial or a monomial. And a monomial is a term in simple words. And a term would have a number and some variables. Sometimes even a number itself can be referred to as a term. In this case, I've got 6x squared y. That is an example of a monomial. I also have an example 2x. It's another example of a monomial. We also learned at grade 8, grade 9 about a binomial. And a binomial is an algebraic expression which has got two terms, bi for 2. So in this case, I've got the term 3x and the term 6x squared. In this algebraic expression, in this binomial, the terms are separated by a plus sign. So we also always need to remember that in an algebraic expression, our terms are separated by a plus sign or a minus sign. A trinomial, tri for 3, would be an algebraic expression with 3 terms. In this case, I've got 5x squared, 3x minus 4. And you can see they are separated by a plus and or a minus sign. A polynomial, poly means many. So in this case, a polynomial would be an algebraic expression with 2 or more terms. So technically, a binomial, a trinomial are examples of polynomials. And we can have polynomials with 4, 5, 6, and so on terms. What is a term? As we have mentioned earlier on, a term would be that which is separated from the other by a plus sign or a minus sign, like I've explained above here. We have like terms and unlike terms. I will explain the like terms, just a reminder for you. Like terms are those terms that are identical with respect to their variables. So if they have got the same variable with the same exponent, then they become like terms. The unlike terms would be having different variables. They could have the same variable, but with different exponents. Our first lesson, as I have mentioned earlier on, it is to find the product of a monomial and a binomial. For all our calculations today, we are going to use the distributive law. I briefly explain it and show it in this example. A brackets B plus C. I will remind you the brackets stand for multiplication. So the distributive law says the monomial, which is outside the bracket, multiplies the terms inside the bracket in turn, like I've shown here. The A multiplies the B, the plus sign is there, the same A multiplies the C. A times B gives us AB, plus A times C gives us AC. Now, let us look at an example. 4x in brackets x minus 2. I will show it on the board. 4x multiplied by x minus 2. Most of our textbooks will demonstrate this by the use of an arrow. And using the distributive law, the 4x multiplies the x. And after that, the same 4x will multiply the minus 2. Let's see how this is going to pan out. 4x multiplied by x, it gives us 4x squared. And 4x multiplied by minus 2, this is a positive, that is a negative, the result will be a negative. 4x times 2, it gives us 8x. This is how we multiply a monomial with a binomial using the distribution or the distributive law. Our answer becomes 4x squared minus 8x. Now, let us look at an activity. I'm going to give you 2 minutes to multiply these monomials and the binomials. I hope and trust that you have been able to multiply and simplify those the questions that I've given. Now let's see if you've done the correct thing. I'm going to retake the 4 examples on the board, and you can look at how you have done your calculation. You can check your work for any mistakes. We will start off with the first one, which is 3 multiplied by 2a plus 1. We said using the distributive law, the monomial, which is outside the bracket, multiplies in turn the terms that are inside the bracket. 3 times 2a will give us 6a. 3 times 1 will give us 3. Very, very simple and straightforward. We'll move on to the next one, which is 4x, in brackets 3 minus x. Very, very similar to the first one. 4x times 3, it gives us 12x. 4x multiplied by minus x, the sign changes to a negative, and our result is 4x squared. That becomes the product of 4x and 3 minus x. The next question, we have minus 6m in brackets 2m minus n. In this example, I'm very much concerned about the signs. This example gives us more practice with the signs. Once again, minus 6m times 2m, a negative and a positive, will give us a negative. 6 times 2 gives us 12. M times m gives us m to the power of 2. A negative and a negative gives us a positive. 6m times n, it gives us 6mn. And that becomes our answer for that question. Our last example is 2ab plus 6b multiplied by 3a. I put this question here because there is a tendency with students to memorize that normally our monomial is always on this side of the bracket. When they find a situation like that, they get a little bit confused. There is no need to get confused in this example. It's exactly the same as all the others. What I've just done is to change the position of the monomial and put it on that position. Otherwise, the same process is going to happen here. So I'll multiply 3a multiplied by 2ab. And that gives us 6a squared b. They are all positive, so there's nothing to stress about. And then 3a times 6b, it becomes 18ab. So the multiplication in this case is very, very similar to the multiplications that we have done in the earlier examples. In our next lesson outcome, we are going to look at the product of two binomials. Once again, the distributive law is going to be applied. In my example here, or in my notes, I have got a plus b in brackets, p plus q in brackets, which means this bracket is multiplying that bracket. And what we have done here is to take a and multiply it by p, and we get ap. We take the a, it multiplies q, and a times q gives us aq. So what we are doing is that we are taking a term in the first bracket to multiply all the terms in the second bracket in turn. After that, the second term in the first bracket also multiplies the two terms in the second bracket. And that's how we get this expression. We will then look at two examples to demonstrate the product of two binomials. So I will deal with the first example on the board, and then we'll move on to the second example again on the board. 2a plus b times a minus 3b. Using the arrows, I would say the 2 will multiply the a, the same 2 will multiply minus 3b. After that, the b multiplies the a, and the b multiplies minus 3b. This gives us 2a times a, it will be 2a squared. And then the same 2a multiplied by minus 3b. This is a positive, that is a negative, so our final sign would be a negative. That gives us 6ab. And then b times a, it gives us plus ab. And then b times minus 3b squared, minus 3b, it becomes minus 3b squared. Now, the question says we need to simplify this expression. Therefore, we can see that these are like terms. In other words, they carry the same variables with the same exponents. A has got an exponent 1, B exponent 1, A exponent 1, B exponent 1. So they are like terms. So we combine them using that operation there. this becomes 2a squared. Minus 6 plus 1, it becomes minus 5ab, and then minus 3b squared. That becomes our answer. So the multiplication using the distributive law still follows the same process as we did with the monomial and the binomial, only that now we have got two terms in the first bracket to multiply the two terms in the second bracket. We also need to simplify that middle part of the expression which carries the like terms. I'm now going to look at the perfect square, which is example 2. 2x minus 3y squared. This 2, which is the exponent there, is telling us that this bracket is multiplied by itself, which means in expanded form, we'll write it as 2x minus 3y in brackets multiplied by the same bracket, 2x minus 3y. So this expression is the same as that. And we write it in this way so that it becomes easy for us to then do the process of multiplication. In a similar way we did with the first one, 2x multiplied by 2x, it gives us 4x squared. 2x multiplied by minus 3y, it gives us minus 6xy. 3y minus 3y times 2x, again it gives us minus 6xy. Minus 3y multiplied by minus 3y, it gives us 9y squared. Once again, we have got the middle terms and they are like terms. So we need to simplify that part. 4x squared minus, then because there is two negatives, and then it means we add them and keep the sign, which gives us 12xy plus 9y squared. That becomes our answer for that expression or for that question. I am now going to give you 2 minutes to solve the following 3 questions. Then after that, we will do it together so that we can check if you've done any mistakes on the calculations. Right, students, I hope and trust that you were able to multiply these binomials with each other. Now let's go through each one of them. I've already written the 3 questions on the board. We are going to deal with them one by one. then you can check with what you have done if you did it correctly. If you made mistakes, then you can check where you did the mistake. Once again, we have to multiply each term in the first bracket with the terms in the second bracket in turn. Minus 7x times 2x, a negative and a positive, gives us a negative. That gives us minus 14x squared. Minus 7x times 3y, it gives us minus 21xy. Minus 4y times 2x, it gives us minus 8xy. And then minus 4 times that 3, it gives us minus 12y squared. Once again, we have got like terms in the middle of that expression. So we need to simplify that part. Minus 14x squared, which is coming from there, minus 21 minus 8, it gives us minus 29xy, and then minus 12y squared. That becomes our final answer for that expression. For the second expression, we're now involving a monomial and a perfect square in the same example, just to spice up the activity. So this is the same as 3x, and then we have got 2x minus 3 times 2x minus 3. Then what I will do is to keep the monomial first and then simplify the two binomials. 2x times 2x, it gives us 4x squared. 2x times minus 3, it is minus 6x. Minus 3 times 2x is minus 6x. Minus 3 times minus 3, it is plus 9. We then simplify the like terms. That gives us 4x squared minus 12x plus 9. Then at this stage, I can then multiply this monomial with the trinomial that we have created inside the bracket. In a similar process, 3x times 4x squared, it gives us 12x cubed. 3x times minus 12, it gives us minus 36x squared. And then 3x times 9, it gives us plus 27x. And then we can say we have reached the end of that question. So to make our life easy, we need first to simplify these two binomials, and it creates a trinomial. And then we can then multiply this monomial with the trinomial to get our final result. In the last example, again, we've got a perfect square, and we need to simplify that. So it gives us 4b minus 3c in brackets, 4b minus 3c, and then minus in brackets 2bc minus 8c squared. We simplify that. 4b times 4b, it is 16b squared. 4b times minus 3c, it is minus 12bc. Minus 3c times 4b, it is minus 12bc. Minus 3 minus 3 is plus 9c squared. Now you can see here that at this point, there is nothing written there. Mathematically, we know that the coefficient here should be a 1. Therefore, a negative 1 times 2bc, it becomes minus 2bc. A negative times a negative becomes a positive 8c squared, so that we expose everything. Now you can see that there is a bc, and a bc. These are our like terms. You can group them together and then simplify, or you can do it all at once. So this becomes 16b squared. Minus 12 minus 12, it is minus 24. Minus 24 minus 2, it becomes minus 26BC. And then the 9C and the 8C, they are also like terms. So 9 plus 8, that gives us 17C squared. That becomes our final answer. In the last learning outcome, we are going to look at the product of a binomial and a trinomial. And the same law, the distributive law, is going to be used here. 2x times 4x squared, it gives us 8x cubed. That times that, it gives us plus 12x squared y. And then that times that, it gives us minus 2xy squared. We move on to the y, it becomes minus 4x squared y, negative and positive, it becomes negative 6xy squared, and then plus y cubed. Again, we identify the like terms there. You have got x squared y, you have got x squared y, you have got xy squared, you have got xy squared. Therefore, that gives us 8x cubed, 12 minus 4, it gives us plus 8x squared y, minus 2 minus 6, it gives us minus 8xy squared, and then finally plus y to the power 3. Once again, don't confuse these to be like terms because the variables have got different exponents. Move on to the next one. This gives us 4xy times 3x squared. It is 12x cubed y. 4xy times 2y squared. It gives us 8xy cubed. 4xy times minus 4x. It is minus 16x squared y. And then 2 times 3x. It is 6x squared. 2 times 2y, it is 4y squared. 2 times minus 4x, it is minus 8x. Again, we look for like terms, and in this case, we are not going to have any like terms. X cubed y, there's no x cubed y. Xy cubed, there's no xy cubed. X squared y, there's no x squared y. X squared, no other x squared. Y squared, no other y squared, and 8x. Therefore, our answer stops there. We cannot further simplify it. The last example will be 2x times x squared. It will be 2x cubed. 2x times minus 4x, it is minus 8x squared y. 2x times 3y, it is plus 6xy squared. 3y times x, it is 3x squared y. 3y times minus 4x, it is minus 12xy squared. 3y times that one, it is plus 9y cubed. Again, we look at like terms. Here we'll find that x squared y, they are like terms. 6xy squared minus 12xy squared, they are like terms. This gives us 2x to the power 3 minus 8 plus 3, that gives us minus 5x squared y. 6x y squared minus 12y squared, it gives us minus 6xy squared, and then plus 9y cubed. That becomes our final answer. In this lesson, therefore, we have learnt the distributive law of multiplying algebraic expression. It is also very important to remember what happens to the signs when you multiply the terms. Until we meet again, have a wonderful time.